My student Rahul asked me a very interesting doubt that is related to friction. Actually, a lot of people have doubts in friction. There are a lot of misconceptions in friction. Let us look at this question first. The two blocks shown are initially at rest. So here you have these two blocks that are initially at rest. Then a horizontal force of 30 newtons is applied on the 8 kg block. Okay? Assume that G is 10 meters per second square and the coefficient of friction is mu equal to 0.2 between any two surfaces in contact. That is, between the 2 kg and the 8 kg block, they are in contact. So the coefficient of friction is 0.2. Between the 8 kg block and the floor, the coefficient of friction is 0.2. Okay? Find the acceleration of the 8 kg block and the friction force on the 2 kg block. So that is the question. Let us first look at how Rahul tried to solve this. Okay? So Rahul's doubt is this. He says, I'm taking these two blocks. Let me draw the free body diagrams for them. So on the 8 kg block, there is this 30 newtons force. But since the 2 kg block is on the 8 kg block and there is friction, they are going to both move towards the right. Okay? So the normal force here, because you can think of this as 2 kg plus 8 kg, the normal force will be equal to how much? 100 newtons. Why? Because 2 kg plus 8 kg is like 10 kg. mg will be 10 into 10, 100 newtons downwards. So the normal force here will be 100 newtons. And because this is 100 newtons, the friction force is going to be like this. How much? Mu times N1, mu is 0.2. 0.2 times 100 is 20 newtons. So this friction force is 20 newtons. Okay, the question asks us what is the acceleration. So Rahul's answer is that obviously it has a horizontal acceleration, 30 newtons like this, 20 newtons like that. So 30 minus 20 will be the net force in that direction divided by this mass 8. So 30 minus 20 divided by 8, 10 by 8 is 1.25 meters per second square. So that is the acceleration of the 8 kg block, A8. This is what Rahul has derived, right? And then the second part is what is the friction force on the 2 kg block. Now this is not the friction force on the 2 kg block. So on the 2 kg block, why is there a friction force? Well, the 2 kg block has a gravitational force of mg, which is 20 newtons downwards. And so there must be a normal force, which is 20 newtons upwards on the 2 kg block. And so it must have a friction force, which is mu times N2. Mu is 0.2. 0.2 times 20 will be 4 newtons. What direction? Since it's moving this way, Rahul says it's going to be in this direction. Mu times N2, which is 0.2 times 20, 4 newtons. Now, he's got this answer, friction 4 newtons, and he's got this fellow's acceleration, right? 8 kg block's acceleration, 1.25 meters per second square. Now, many of you may think that this is actually right, but it turns out both of these have been marked wrong. And Rahul's question is, what is wrong with what I have done? So that's what you need to find out. So can you please pause and try to figure out where did Rahul make a mistake? Before we get to Rahul's doubt, we must address 3 very important misconceptions in friction. The first point is, when a block has a friction force acting on it, you must always ask the question, who exerts this friction force? Okay? Friction force is exerted by one surface on another. So, if there is a friction force acting on this green block, it must come from somewhere else, another surface. So, let us say that this green block is moving on top of this orange block. So, the green block obviously is touching the orange block. I have shown it separated here so that you can see it more clearly. So, this orange block is exerting this friction force on the green block. But Newton's third law tells us that this means the green block must also exert a friction force on the orange block. So, these two must be equal and opposite. So, you must remember this point, very, very critical. Usually people say that when a block is moving on the floor exerts friction on the block. But they forget that the block also exerts a friction force on the floor. Okay, so this block exerts a friction force on the bottom block also. So keep that point in mind. Okay, they are both equal and opposite. The second important point is people always assume that friction opposes motion. This is wrong. Friction does not oppose motion. Friction opposes slipping. What is the difference? Let us say that these two blocks, okay, the green block is on top of this orange block. They are both moving to the right. The green block is moving at 3 meters per second. The orange block is moving at 5 meters per second. And the green block is obviously in contact with the orange block. Now, people think that, oh, because the green block is moving like this, the friction force must be in the opposite direction. But friction doesn't oppose motion. Friction opposes slipping. What is the direction in which the green block is slipping on the orange block? Let us think about this. The orange block is moving 5 meters per second. It is faster than the green block. So the orange block will move more, the green block will move less. That means the green block is slipping backwards on the orange block. Relative to the orange block has moved forward, the green block is behind. Well, it is also moving forward overall, but it is behind the orange block because it moved less. So the green block is slipping backwards relative to the orange block. It is moving forward, but it is slipping backwards. And friction opposes slipping, so friction will not be this way, friction will be in the forward direction. Do you understand? The friction on the green block is in the forward direction because the green block is slipping backwards. Now you can also ask the question about the orange block. Orange block is slipping forward, right? If you think in terms of the green block moved less, the orange block went ahead, too much ahead. So the green block will try to pull the orange block back. So the friction force on the orange block will be backwards. Are they equal and opposite? Yes, they are equal and opposite. In fact, let us think about this. This friction will try to speed up the green block and this friction will try to slow down the orange block, trying to make them move with the same speed. It may not succeed, but that's what it is trying. Friction always opposes slipping, not motion. Keep this point in mind. This is a very, very common mistake people make. The third mistake that people make is that they assume friction force value is equal to mu n always. That is not correct. Friction is equal to mu n only when the surfaces are slipping or they are about to slip. Like in this case, the surfaces are clearly slipping, so friction force will be equal to mu n. But what if the surfaces are not slipping and not even about to slip? Then friction force will be less than mu n. In general, you should say friction force is less than or equal to mu n. Suppose I have these two blocks and the green block is on top of the orange block and let's say they're moving together, they're not slipping. In this case, the friction force on the green block will be less than mu n, and similarly the friction force on the orange block can be less than mu n. Of course, when they are just about to slip, then it will become equal to mu n. In general, the friction force will be less than or equal to mu n. Don't assume that it is always equal to mu n. So, okay, this is something that can land you in trouble. So once you have understood that there are these three different misconceptions that are very easy, very common for students to make, we can then correct for these when we are solving problems. So using this, let us now answer Rahul's doubt. We are now ready to address Rahul's doubt. Okay? So Rahul first separates out these two blocks, 2 kg block, 8 kg block. There is this 30 Newton force acting on the 8 kg block. Now that is going to make both the blocks move to the right. And so if I take the 8 kg block, there is going to be a friction force from the floor acting to the left. How much friction force? For that I need the normal force acting on the 8 kg block. How will I find the normal force? Now the 2 kg, 8 kg, both you can think of them together as 10 kg pressing down. So mg will be 10 into 10, 100 newtons downwards, and so the normal force will be 100 newtons. Of course, You should do this step by step. The 2 kg exerts a normal force here, and you should take that to find this out. But what Rahul has found is correct. So we will keep it as it is. Now, the friction force acting on the 8 kg block from the floor will be mu times N1. Mu is 0.2. 0.2 times 100 is 20 newtons. So this is the friction force acting on the 8 kg block at the bottom. So this statement is also correct. So I will leave it as it is. Okay. Now what Rahul does is to say that if you look at the 8 kg block, it has a 30 Newton force and it has 20 Newton force this way. And so the acceleration must be 30 minus 20, right? That is the net force in this direction divided by the mass 8 kg. So 10 by 8, 1.25 meters per second square in this direction. So that is what he gets as the acceleration of the 8 kg block. Now this turns out to be wrong, and we will see why this is wrong. Let us continue with the rest of what he has done. So the 2 kg block, what is the friction force on the 2 kg block? That is the question, right? That's also one part of the question. So for that, he says, well, the 2 kg block is sitting on this 8 kg block. So gravitational force mg is pulling it down. So there must be a normal force like this, which is N2, which is 20 newtons. Why? M into G, 2 into 10, that is the gravitational force. Gravitational force is 20 newtons. So the normal force must be 20 newtons. So this is also correct. He's not drawn the free body diagram correctly without the mg. Similarly, without the mg here, there's also a normal force acting there. So all those things are missed, but it doesn't matter because we are only interested in the horizontal direction. We are only looking at the normal force to find the friction force, right? So this normal force, Rahul then says mu times N2, 0.2 times 20. So that must be the friction force, which is 4 newtons. Okay, and he puts the direction this way. Why? Because the object is moving in that direction. First of all, this itself is wrong. Why is this wrong? Let us think about it. Okay, now this 2 kg block was originally at rest, right? Initially at rest. Why is it moving to the right? Because of friction. Now friction, if it acts in this direction, how will this block move to the right? It's a problem, right? So the 8 kg block is moving to the right, and if the 2 kg block doesn't move, the 8 kg block will pull the 2 kg block in that direction. So friction must act in this direction, not in the opposite direction, but in the forward direction. So first of all, the friction force is in the forward direction. Okay. Okay. Now, if there is a friction force acting on the 2 kg block, please remember there must be an equal opposite friction force acting on the 8 kg block, right? This surface exerts a friction force on that surface. So that surface will exert a friction force on this surface. How much? Same force, F2. If F2 is 4 there, F2 is 4 here. But if F2 is 4, then clearly what we have done here is not correct, right? Because there is 30 newtons in the forward direction, there is F2 and 20. So that means I should change this to 30 minus 20, and this is 4 newtons, so minus 4 newtons. So let us change this by putting in minus 4. Then what do you get? 30 minus 20 is 10, 10 minus 4 is 6, 6 by 8, 6 newtons by 8 kg, that is 3 by 4, 0.75 meters per second square. Is that correct? Well, it turns out that is also not correct, and we will come to that in a minute. Okay? So this is the acceleration you get once you put this force. So Rahul missed this force. Okay? He also got this force direction wrong. But let us continue and now look at, if there is this force of 4 newtons, how much must be the acceleration of this block? Well, this block has a horizontal force 4 newtons. It's a 2 kg block. Net force in the horizontal direction by mass 4 newtons by 2 kg will give me 2 meters per second square. That was not asked, but the moment you calculate that, you see something interesting. The 2 kg block is accelerating towards the right faster than the 8 kg block, because the acceleration of the 8 kg block is 0.75. The acceleration of the 2 kg block is 2 meters per second square. What is this telling us? This is telling us that this friction force, which was trying to stop these two from slipping, okay, first let's think. Suppose there was no friction, the 2 kg will remain there and the 8 kg will move forward. So the 2 kg will be slipping backwards on the 8 kg block, which is why to prevent that slipping, friction acts in the forward direction. So friction is trying to prevent the 2 kg block from slipping backwards on the 8 kg block. That's why it's acting in the forward direction. You have to understand this important point. Now, can the friction be so much that it makes this block now slip in the forward direction? Now you have made the 2 kg block much higher acceleration than the 8 kg block. So what is going to happen? The 2 kg block is accelerating faster than the 8 kg block. So it is slipping forward. But friction arises to stop slipping. How can it make the object slip in the opposite direction? That's not possible. So then what is the mistake? Will you say friction is in this direction? No, you can't say that because this object was actually slipping in the backward direction. So friction acts in the forward direction. So that is correct. Except, what is the mistake? Remember that friction need not be equal to mu n. Friction is equal to mu n when the objects are slipping. When the surfaces are slipping, then you can be sure that friction must be equal to mu n. But here you can't be sure that they are slipping. Maybe they move together. Think about that. If they move together, the friction force will not be equal to mu n. It will be less than or equal to mu n. Okay, so the friction force here has to be less than or equal to 4. Right now, putting in a friction force of 4 means that this is accelerating too fast and this is accelerating too slowly. So you must reduce the friction force. It is not equal to mu n. So let us redo this by calling this F2. I don't know what the value is. I know it must be less than 4. Okay, but I don't know what it is. Now, this is also not 4, right? Whatever the value is there, the same value you must put here. Now, let us first try to calculate what will be the acceleration of this block. Well, the acceleration of this block will be 30 minus 20 minus F2 divided by 8. 30 minus 20 minus F2 divided by 8. In that direction. Okay, so that is the acceleration of the 8 kg block. What will be the acceleration of the 2 kg block? Well, there's only one horizontal force, F2. So F2 by 2. So that will be the acceleration of the 2 kg block. Now, why is the friction force not equal to mu n? Because these blocks are not slipping. But if they are not slipping, what does it mean? They both must be moving together. Because if they are moving differently, then they will slip. So if they are moving together, both these accelerations must be the same. That's why I wrote A8, acceleration of this 8 kg block is equal to A, acceleration of the 2 kg block is equal to A. So both of these are equal. Now I can use the fact that these two are equal to solve and find out what is F2. So F2 by 2 must be 30 minus 20 minus F2 by 8. Well, that is 10 minus F2 by 8. F2 by 2 must be 10 minus F2 by 8. If I cancel this, will be 4. Take it there. 4F2 is equal to 10 minus F2. If I take the minus F2 to this side, I'll get 5F2 is equal to 10. F2 is equal to 10 by 5, 2 newtons. So the friction force is 2 newtons. Is that allowed? Yeah, it has to be less than 4 newtons. It is definitely less than 4 newtons. And if I take F2 is 2 newtons and put it in here, 2 by 2, that will give me 1. So the acceleration of this block will be 1. But both blocks are the same acceleration. But suppose I put it here, what will happen? I'll get 10, right? 30 minus 20 is 10, minus 2 is 8. 8 by 8 is 1. So either way, I'm going to get the acceleration of both blocks is 1 meter per second square. So this is the correct answer. The acceleration of the 8 kg block is 1 meter per second square in this direction, and the friction force on the 2 kg block is in the forward direction. How much? F2 is 2 newtons. F2 is 2 newtons. Okay. Now we can do a simple check. Because these two are moving together, we can say that these forces are internal forces. Let's ignore them. Let us look at this as a single big block. How much mass? 2 plus 8, 10 kg mass. but there is one friction force which is 20 newtons. Now here I have used F is equal to mu n. Is that correct? Yes, because this block is slipping on the floor. This 2 kg is not slipping on the 8 kg, but the 8 kg is definitely slipping on the floor. So therefore this friction force is equal to mu n. Okay. But if I now look at this whole thing together, there is only that friction force, so which is 20 newtons acting on the 8 kg's bottom surface. Right? Now, if I think of this as a single system, what is the net force acting on it? 30 minus 20, which is 10 newtons. But it is going to accelerate both of them together. So 2 plus 8, 10. So 10 newtons by 10 kg, the acceleration is 1 meter per second square, exactly what I got. Now that I know that this is 1 meter per second square, this fellow's acceleration is 1 meter per second square. That means F2 must be 2 times the acceleration. So it must be 2 newtons. So this is another way to solve. Once you have realized that these two are moving together, then you can actually treat it as a single combo block, solve it, find out the acceleration, use the acceleration to find out what is the friction force. Key point, this friction force is not equal to mu times N2. It is not equal to 4 newtons. It is just equal to 2 newtons. It is less than mu times N. So I hope you have understood how to solve this problem, and also Rahul's doubt has got clarified. Okay. If you like this video, hit the subscribe button below. And if you have other physics or math doubts, please ask them in the comment section. I will take one of the interesting questions there and make the next video. See you all soon.